You know, every road we drive on, every building we walk into, they all depend on concrete. But the concrete that holds up our modern world isn't just a simple mix of sand and rock anymore. It's become a high-tech, precisely engineered material. So let's pull back the curtain and see how it's really made. And it really starts with a simple question. Have you ever wondered why the concrete holding up a massive skyscraper is so much stronger than the stuff in your sidewalk? Well, the answer isn't just about using different ingredients. It's all about achieving absolute precision and control. You see, for a long time, making concrete was full of guesswork. And for the kinds of massive structures we build today, guesswork isn't just sloppy, it's downright dangerous. This forced a complete revolution in how we produce concrete.
Back in the day, everything was mixed right on the job site. You had workers with shovels and buckets, just kind of eyeballing the amounts. The problem? You'd get uneven strength, a lot of wasted material, and dangerous weak spots. The modern way, well, it moves the whole operation into a controlled factory. Here, precision engineering makes sure every single batch meets the exact same high standard. And that means safer, more reliable buildings for all of us.
Okay, so this idea of strong, reliable concrete, it actually starts way before the mixing. It all begins with the raw ingredients and making sure they are perfect, pure, and measured down to the gram.
So the basic components are pretty simple. You've got your aggregates, that's just sand and stone. Then there's cement, which is the glue that holds it all together. You add water to make the cement work, and sometimes tiny amounts of special chemical admixtures to give the concrete unique properties. In a modern plant, all of these are stored in their own separate sealed-off environments, like in these giant bins and silos, just to make sure nothing gets contaminated.
But the real secret, the absolute key to strength, is the water-to-cement ratio. Think of it like baking. If you add too much water, you get weak, soupy concrete that cracks easily. Too little, and it's thick, clumpy, and impossible to work with. Nailing that ratio is everything. It's the single most critical factor for strength. But here's the tricky part. The sand you use is never totally dry. Its moisture level can change every single day, even every hour, depending on the weather. So if you just add a fixed amount of water to sand that's already wet from last night's rain, you could ruin the entire batch. And that could compromise the safety of the whole structure. So how do modern plants handle this? With some really smart technology. They use microwave sensors that measure the exact amount of moisture hidden inside the sand in real time. A computer sees that data, instantly calculates how much less water is needed, and adjusts the recipe for that specific batch. This ensures that water-to-cement ratio is perfect every single time. Precision replacing guesswork. So, with all the ingredients measured out perfectly, the process moves to the heart of the plant. This is where automation takes over to completely eliminate human error and guarantee consistency. The entire plant is basically run by a central computer. It's the brain of the operation. It gets data from all the sensors, it calculates the perfect recipe, and it sends commands to all the machines, telling a gate when to open or a conveyor when to stop. There's a human operator, of course, but they're really just there to monitor the system. This kind of automation is what gives us stronger, longer-lasting structures.
All those precisely weighed materials are then sent into a huge, high-performance mixer. And in just a few seconds, these incredibly powerful machines blend everything together, making sure every single grain of sand and stone is completely coated with that cement paste. This gives you a perfectly uniform mix, which is absolutely critical for preventing any weak zones later on.
All right, the concrete is perfectly mixed. But now, a totally new challenge begins. The whole process becomes a frantic race against time. See, from the moment that water touches the cement, a chemical reaction starts, and the clock is officially ticking. You generally have about 90 minutes to get that concrete from the plant to the job site and poured into place before it starts to harden. Time is absolutely critical. In fact, engineers literally treat fresh concrete like a perishable product, like milk or fresh vegetables. The delivery trucks are all tracked with GPS, and their routes are planned out carefully to make sure there are no delays. Any hiccup could compromise the quality of the material before it's even in the building. Now, all this control and technology, it doesn't just make concrete stronger and safer. It's also making it a lot more sustainable. That same precision is helping us tackle the industry's environmental footprint. Modern plants are now engineered to be much greener. For instance, they use materials like fly ash, which is actually an industrial byproduct, to replace some of the cement. And since cement production is very carbon intensive, that's a huge win. They also recycle and reuse water, and that same automation that ensures quality also means almost nothing gets wasted. And the result of all this is pretty significant. When you combine smarter materials with this kind of precision technology, the carbon footprint of what we call green concrete can be dramatically lower than the old traditional mixes. And you get all that environmental benefit without sacrificing any of the strength.
And it's not stopping there. The technology is getting even more advanced. We're heading towards a future of intelligent concrete, literally concrete with tiny sensors built right inside it. These sensors can monitor the structure's health and strength in real time, giving us safer roads and bridges that can tell us when they need repairs. So, the next time you look up at a skyscraper, just remember this. Its incredible strength doesn't come from just stirring some stuff together. It comes from a complex system of sensors, computers, and absolute control. The big takeaway is that modern concrete isn't just mixed, it is precisely engineered.